Okay, now we're back. Sorry about that. My battery was going to die. I didn't want it to die middle through a problem. Okay, so now that's how you simplify just a simple coefficient and a radical. Now you're multiplying coefficients and radicals. This actually has 3 steps to it. Okay, first thing you do is you multiply your coefficients 3 and 5. Okay, so 15. Then I make sure my roots are the same kind of root. They are. They're both cubed roots. If they're not the same kind, then it's a headache that you don't really learn until you get into trig. Okay, but they are the same. So then what I'm going to do is make a cubed root, and then I'm just going to multiply the numbers inside. So 54 times 7. Okay, so that's 378. This is how I like to do it. Okay. Some people will have you simplify them separately, but I'm a big fan of this strategy here. Okay, so now where I'm at is I'm exactly where I want to be. There's just a coefficient and a radical. So I do in the same process I did on the first example. So 15, and then 378. Let's see what that looks like for cubes. 378's not on the list, so I need to make 2 of my own cube roots. And see if 378 divides by anything. So 378 by 343 does not work. 378 divided by 216 does not work. 378 divided by 125 is a fail. 378 divided by 64, nope. 378 divided by 27, nope. Yeah, actually 27 worked. 27, okay, so 27, and then 378 divided by 27 is 14. So you get rid of the cube root 27, and that turns into just another coefficient because the cube root 27 equals 3. Okay, then you multiply your coefficients. 15 times 3 is 45. Cubed root of 14. Okay, 1, 2, and 3. So they're both square roots, so that's good. So I multiply my coefficients, that's 6. And then I multiply 60 and 5, that's 300. Okay, now we're doing square roots, okay. Perfect squares, 300 is not a perfect square, but it should be pretty easy to see what 300 divides by. Well, it's divisible by 100, I know that. 300 divided by 100 is 3. Okay, so we know that the square root of 100 is 10, and then I multiply the coefficients, and that's 60 square root 3. Okay, next. I take 5 times 7, that's 35, and then I take the square root of 9 times the square root of 7, that's the square root of 63. Okay, now, remember, it's important to write times so you don't do something dumb. You're not going to add at all on these problems. If you don't see a plus sign, you're not going to add. You can't bring your own plus sign into a math problem. It doesn't work that way unless you have a plus negative. Okay, so 63. It's not a perfect square. No. Yeah, it divides by 9. So 63 divided by 9 is 7. So the square root of 9 is 3, and then I multiply the new coefficients. So that's 105 square roots of 7. Okay, another multiplication. So you take 2 multiplier coefficients, it's negative 8, root 4, and then 50 times 16 is going to be, I think it's 800, yep. Okay, so I'm looking at force. Again, I'll emphasize for about the 8th time in these videos, you need to look at the correct list. You always need to know what type of root you have, what type of radical, what degree the radical is. Okay, so 800, it's not divisible by that or that. 800 is divisible by 16. Actually, I know it because I just multiplied 16 to get it. Okay, so negative 8. And then I bust that up into a product of 2 radicals, and that's going to be 16 and 50. Now, a lot of people will make the mistake of getting rid of that and putting 4, but it's wrong because it's a fourth root, not a square root. Okay, so the fourth root of 16 is equivalent to 2. Okay, so now I find the product of my coefficients. That's negative 16, and then root 4 over 50. Okay, now let's go okay, pause the video and then make sure you know how to do 3 and 4. Okay, now the next thing's a whole different ball game. Now you're adding and subtracting. Now, you know, like in a problem like this, don't write this down, but you know how there's, in this expression, there's only certain things we can add together. It's called like terms. We'd add the x's, can't add 7y to anything, then we'd add the 2 constants here, okay? Well, the same goes for radicals. We can only add 2 coefficients, like 3 and 7, if the radicals connected not only are the same degree, they're both square roots, but they also have to have the same number inside. Okay? It is not the same. You can't add 3 and 7, then add 50 and 72 and go from there. Okay? It's the same process. It's called like terms. Okay? To get these to be like terms, you have to have not only the same type of root, which we already have, they're both square roots, but you also have to have the same number underneath. So what I like to do is kind of arrange a table here, and I'm just going to write the roots separately. So 3 square root 50 and 7 square root 72. So I'm just going to work on simplifying 3 square root 50. When it's just a coefficient and a radical, there's 2 steps. So first I want to look at my sheet, and it's a square root, so we're looking at the squares list, and 50 is not on here, but it is divisible by 25. So I drop the coefficient 3, and I break that up into 2 roots. So 50 divided by 25 is 2. So we get rid of that, and that's 5. Now, a lot of people will think, oh, you add 3 and 5. No, you don't add 3 and 5. You still times them. 3 and 5 is 15. Square roots of 2. Okay, now in the other one, now I come over here and I do the same thing. 72, not a perfect square, so I drop the 7. And I see if 72 can divide by any of my perfect squares. So it's not divisible by 64 or 49. But 36, yeah, you bet. So 36 and 72 divided by 36 is 2. Okay, so let's get rid of that first one because that's equal to 6. And then again, we find the product, not add. It is an adding problem, but when I'm just doing the roots separately, you're multiplying still. 7 times 6 is 42 square roots of 2. Okay, so now what I do is that is simplified. That is now 15 square root 2. And this has now changed into 42 square root 2. Now I have the same square root, so I write the square root of 2, and I add the coefficients. 15 plus 42 is 57. Okay, next one. If you have a minus, just make it plus negative. Okay, so you're adding the negative 5. And again, I want to be able to add the coefficients, but I can't until the 16 and the 250 can change into the same value. Okay, so negative 3 root, it's a cubed root of 16, and then negative 5, and it's a cubed root of 250. Okay. So let's work on simplifying that. So cubed roots here on cubes. 16's not cubed root, 16 is not a perfect cube. So we need to drop negative 3. Okay, and then see on the list what 16 divides by 8, obviously. So 8 and 2. Now remember, it's a cubed root, so the cubed root of 8 is equal to 2. Now we find the product of negative 3 and 2, so that'd be negative 6 root 2, okay, cubed root. Okay, and then likewise on this one. Okay, so I drop the negative 5, And then we're going to check out the cube root of 250. It's not a perfect cube, so I need to split that. 250 is divisible by 125. So 125 and 250 divided by 125 is 2. So the cube root of 125 is 5. Okay, so now I find that product, and that's negative 25. Radical roots and radicals mean the same thing. Okay, so radical root means the same thing. So it's cubed root. Okay, at least in my book. Okay, so this changed into negative 6 with a cubed root over 2. And this changed into negative 25 with a cubed root over 2. Okay, this has been successful because now I have my roots as identical. So negative 6 and negative 25 adds to negative 31. Okay, now we're dealing with fourth roots. Again, it's a coefficient of 1 if you don't have one, if that makes you feel better. Okay, coefficient of 1. So 7 is my coefficient with a fourth root, 405, and then 1, and then with a fourth root of 3,125. Okay, so I drop the 7, and then I go check out the fourth roots. Okay, 405 is not on this list, so I need to make 2 roots. Remember, they're fourth roots. And see if 405 divides by something here. Well, 256, that's a fail. 81, yeah, so 81. And then what was 405 divided by 81 is 5. Now, a lot of people will put 9. That's a mistake, okay, because it's not a square root. It's a fourth root, so that's 3. 7 times 3 is 21, radical 5, okay, and it's a fourth root. Okay, now if you want to drop the 1, that's fine. The 1 is not necessary, okay, so 3125, we're in the fourth roots. 625, bingo. Okay, so I divided by 625, and 3,125 divided by 625 is 5. Okay, so what's the fourth root of 625? It's 5. Then I find the product, it's just 5. And then root 5, so it's a 4. Okay, so this was simplified into 21 fourth root of 5, and the other one's simplified into 5 fourth root 5. Okay, so the roots are identical. They're both fourth roots of 5. And then 21 plus 5 is 26. Okay, last one. I'm going to give you a little pointer how you can make this go a little quicker. So 2 fifth root over 64. And then negative 6 fifth root over 486. Okay, so it's a little two-step process here. So I drop my 2. Now let's look at our fifth roots. You got to look on the right list. Now 64 may not be here, but it does divide by 32. So I divide by 32, and that is 2. Okay, now here's a little tip on how you can make this go quicker. You know you want a 2 right here, okay? Just from the first one, I want there to be a root 2. So let's divide 486 by 2 and see what happens. And that's 243. Okay, so remember we're on fifth roots. So the fifth root of 32 is 2. So it's going to be 4 root 2. It's a fifth root. And 243, what do you know? 243 is on here, okay? Amazing how that works. And find that product. That's going to be negative 18 root 2, and it is a fifth root, okay? So this simplified into 4 fifth root 2, and then negative 18 fifth root over 2. Okay, so they both have fifth root 2. Then 4 plus negative 18 is negative 14. Okay, that's really all I had to say on that. Now I think you should know how to probably add those. I hope it's been informative.